The topic of this video is analyzing the graph of a rational function. This is a continuation of the previous video. Alright, so here we are one more time looking at r of x equals x over the difference x squared minus 16. We've done steps 1 through 5. The only thing left now to do is step 6. Let's learn about step 6. Step 6 says, use the zeros of the numerator and denominator of r to divide the x-axis into intervals. Note that we're back to using the original r function provided at the beginning of the problem. Determine where the graph of r is above or below the x-axis by choosing a number in each interval and evaluating r there. Plot the points found. Okay, well, since we're back to using the original r, I'm going to go ahead and erase this factored version. And we're going to find the zeros of the numerator and the zeros of the denominator. Remember, a 0 is a value of x that makes y 0. So our numerator polynomial is x. When we set that equal to 0, we get x equals 0. Our denominator is x squared minus 16. When we set that equal to 0, we get that x squared equals 16, x equals plus or minus the square root of 16, x equals plus or minus 4. So there are three values that are going to go on a number line, 0, 4, and negative 4. Okay, the reason why these values go on the number line is because we already know something interesting about each one of these. What we don't know is what's happening in the middle. So we're going to pick one number in each interval created by these breaking points on our number line. For example, we're going to choose one number that is to the left of negative 4. We're going to choose one number that is between negative 4 and 0. We're going to use one number between 0 and 4, and we're going to use one number that is bigger than 4. And it's up to us to decide which number we would like to use. So my advice is pick easy numbers. For example, the easiest number that is bigger than 0 but less than 4 would be 1. The best number between 0 and negative 4 would probably be negative 1. The best number bigger than 4 would probably be 5. And the best number to the left of negative 4 would probably be negative 5. Now, truth be told, you can use any number you want that is in each of these regions. For example, between 0 and 4 is pi. So if you really wanted to use a crazy number, you could. Pi, 3.14159, etc. But pi would make the math really, really hard. 1 would make the math really, really easy. And what do you want your math problem to be? Easy or hard? I'm guessing the answer is easy, and that's why we choose easy numbers like 1 and negative 1. The reason why I chose 5 is it's bigger than 4, which is a rule I have to follow, and it's the first integer after 4. Notice I didn't use a crazy number like 4.681 or 1,000. I picked a small integer that was in the region that I was interested in. Now what I'm going to do is plug in each one of these numbers one at a time into my function. This is going to give me 4 points that I can then put on my graph, which is going to help me create the picture of my function. So negative 5 comma something, negative 1 comma something, 1 comma something, and 5 comma something. Let's plug in each one at a time. First, r of negative 5 would be negative 5 over negative 5 squared minus 16. That's negative 5 over 25 minus 16, which is negative 5 ninths. As a decimal, negative 5 ninths is approximately equal to 0.55, and since there's a bar over that, we'll actually go ahead and say it's exactly equal to, equals 0.55 repeating, with the negative, of course. Okay, negative 0.55 repeating. So the ordered pair will be negative 5 comma negative 0.55 bar. All right, let's do the next one. R of negative 1, so I get negative 1 over negative 1 squared minus 16, which is negative 1 over 1 minus 16, which is negative 1 over negative 15, which is positive 1/15. And this one I think I am going to have to approximate here. Well, this one, well, I could use a repeating as well. 1 divided by 15 is 0.06 repeating. So equals 0.06 bar. Okay, that was r of -1. Next one would be r of +1. So I get 1 over 1 squared minus 16, which is 1 over 1 minus 16, 1 over -15, which is negative 0.06 bar. And finally, r of 5 is equal to 5 over 5 squared minus 16, which is 5 over 25 minus 16, which is 5/9, which is positive 0.55 bar. All right, so now that I have all of these values, I can go ahead and fill in my missing y's on my chart here. And now I have everything I need in order to create the graph of my function. I just need to put it all together. All right, so here we go. We're ready now to create our graph. Okay, so the first thing I notice is that our x's need to go from the smallest, which is -5, to the largest, which is 5. In fact, we'll go a little bit beyond that. So 1, 2, 3, -4, -5, -6, -7, and -8. 1, 2, 3, 4, 5, 6, 7, 8. And then the y values, these are all small, 0's pretty small, y values are pretty small. So I'll just keep the scale consistent. Okay, let's begin with the asymptotes. We got a couple of those. So we have vertical asymptotes, 2 of those, x equals 4 and x equals -4. So let's draw those. X equals 4 is a vertical line. X equals -4 is a vertical line. So we're going to get 2 vertical lines here. All right, there's the 2 vertical asymptotes. The horizontal asymptote is y equals 0, also known as the x-axis. So we kind of have sort of a big H here. We can see we've got a horizontal asymptote at the x-axis and 2 vertical asymptotes at the -4 and +4 locations. Okay, now we can get to plotting some points that we know. We know that our graph goes through the origin, 0, 0, and that is the only intercept in the whole graph. It's the only x-intercept, it's the only y-intercept, it's the only intercept. We know there are no holes in our graph. All right, now we're going to plot the points that we know. So -5, -0.55 repeating. -5 and -0.5, so that'd be about here. Next one, -1 and 0.06. And I have to admit, I don't remember now if this was -0.06 or +0.06. Let me just plug in real quick here. If x was -1, I think that was supposed to be -0.06 repeating. Thinking. -0.06 repeating. X is -1, so the top would be negative, and the bottom would be negative, and negative divided by negative is a positive. Okay, that one really is positive. Maybe this one was the negative. 1 over, yeah, this one was the negative. All right, a little sloppy of me, sorry about that. All right, -1 and 0.06 repeating. So -1 and 0.06 repeating. So that's a very tiny, tiny y value that is positive. 1 and -0.06 repeating would be here. And then 5 and 0.55 would be about here. Okay, so with that information, we should be able to create our entire graph. We know that there are no places where we are going to cross the horizontal asymptote except here at 0, which means that when we go from this point to this point, we can't go down across the horizontal asymptote to approach this vertical asymptote, which means we have to go up. So our graph is going to go up. Similarly, when we go from this point to this point, we can't go up because then we would have to cross the horizontal asymptote again, which we're not allowed to do. So it forces us to go down, and so this has to go down here. Next, we know that for both of our asymptotes, if it was up on one side, it's down on the other. So looking at this asymptote, since we went up on this side, that means we have to go down on the other. So our graph has to look like that. And because we already crossed the horizontal asymptote at the only place we're allowed to, we cannot cross it again, so this forces us to go over here and approach our horizontal asymptote that way. All right, similarly, in this spot, we cannot cross the vertical or the horizontal, so the only thing that we can do here is go up and to the right. And notice that for this vertical asymptote, we have what we expected, which is down on one side and up on the other. All right, there we go. We have made it through all 6 steps, and we have completely finished the graph of our rational expression.